Hey everybody, today we're going to start a new unit and we're going to still be using trig, but we're going to use it more of a theory, more as a theoretical approach than physically taking numbers off a triangle and writing cosine, stuff like that. So at the top here, these are our trig identities. Now an identity is an equation, which just means it has an equal sign in it. It also means that it's always going to be true. So that's what we have here. You can call them formulas if you want to, rules. We just call them identities when dealing with trig. So we have two kinds, quotient, meaning we turn this into a division problem, and reciprocal, meaning we just flip something over. And if you look, every single word can be written in terms of sine and cosine. And that is the number one important thing to remember. We can take any single word we want and turn it into either sine or cosine or a combination of sine and cosine. So tangent is sine over cosine. Cotangent is cosine over sine. So I remember it as if it starts with right? It starts with cotangent, then it starts with cosine. And tangent is the other way. So we're just going to jump right into this. This has a tendency to be sometimes frustrating. Over here on the side tells you kind of some strategies. There's really no rules. There's really no order. That makes it a little bit rough also. So they're saying rewrite using quotient and reciprocal identities. I think a better way to say this is to just rewrite with sine and cosine only. So if you don't know what to do, turn every single word into sine and cosine. The second one is to use Pythagorean identities. This one, we will get to the Pythagorean identities at the bottom of the page, but in problem number 1, we're actually going to use those Pythagorean identities. It's a tiny bit out of order, so I apologize for that. So maybe we'll do number 1 last. And that's it. I mean, that's it. So if you don't know those identities, this is going to be almost impossible. So let's go through them. I'm going to go through each and every single identity more than once probably. So I'm going to skip number 1. All of this is being multiplied together. So we can just turn this into sine and cosine only. So sine is, of course, itself. Cotangent is cosine over sine. Look up. Look at the top of the page there. You have to know that. And secant is 1 over cosine. Now, when you reduce a fraction, you can reduce anything on the top and anything on the bottom that matches. These are, of course, all 1s. When you multiply, straight across the top, you get a 1. Straight across the bottom, you get a 1. And so the answer here is 1. The hardest part about this is, how do I know when I'm finished? Because there's no way of knowing. The directions up here say we should end up with a numerical expression or a single trig function. So you get a number or a word, and that's the goal. If you take a look at number 3, because number 3 is a lot like number 2, we're going to take this, and now here they're using theta. So if you don't like theta, you can use x if you'd like to, but I'm going to use what they do. So cosine theta, this could be over 1. Cosecant is 1 over sine. And then the whole thing just has cotangent on the bottom. I'm just going to do one thing at a time. So straight across the top, straight across the bottom, we would end up with cosine theta over sine theta. Now, cotangent can be rewritten as cosine theta over sine theta. And if you look, the top and the bottom match perfectly, and they reduce to 1. So 1 is a common answer. Now, before I do problem number 1, take a look, please, at this guy right here. Cosine squared plus sine squared equals 1. This is probably the most popular, most used trig identity that we have, besides the ones we just went through with the words. Now, what you can do with this is if you have cosine squared plus sine squared, I don't have the letters there, sorry, equals 1. If you subtract sine squared, you end up with cosine squared equals 1 minus sine squared. You're not going to be told that one. You will always be told this one. You'll be told all 3 of these. You won't be told anything else at the top, but these 3 you'll always be told. Then you can do the same thing by subtracting the cosine squared. So we also know that the sine squared is 1 minus cosine squared. So this one trig identity actually generates 2 more. And we kind of use all 3 of them a great deal. So if we go back up to problem number 1, Secant is 1 over cosine. And then these two are being multiplied together. So I'm going to kind of leave this like this. So we have sine theta, this is over 1. And tangent is really sine over cosine. Now what's nice about this problem is it automatically has a common denominator. They both have the same denominator. I just rewrote the problem a little bit and just made this into one fraction right here. So if we turn this into, because they have a common denominator, we can just rewrite this. 1 minus sine squared goes on the top. And if you remember, down here, 1 minus sine squared is cosine squared. So 1 minus sine squared comes out. And then, of course, cosine squared's going in there. And then, oops, that's theta. And then the bottom has just a plain cosine, that's not going anywhere. And then these can reduce, so we're left with just a cosine on top. And so here's an example of a single trig function. Now we're going to use all of them. I know I just kind of used all of them, but the back is really just more of the same thing over and over again. Just practice. The only way to kind of get familiar with this is to just try them. You have to be pretty aggressive, and you have to be willing to just try something. And if that doesn't work, just try something else. If you can't come up with something else, then move on to the next problem. Now there is a Pythagorean identity for cosecant squared. It is cotangent squared plus 1 equals cosecant squared. Now how you recognize these Pythagorean identities is that the words are squared. Like if you take a look at number 5, there's no squared words there. So we're not going to use any Pythagorean identities. We're going to use, hey, switch everything to sine and cosine. So if you have a word squared, that's what you want to look for, Pythagorean identity. So I'm going to actually leave this cotangent squared. Now we're using the letter A. I'm going to leave that there. The cosecant squared is really cotangent squared. And you use whatever they're using. They're using A, I'm using A, plus 1. I'm going to distribute this negative sign. And then you can see cotangent squared minus cotangent squared, they add up to 0, and the answer here is negative 1. Number 5. Can't use any of those Pythagorean identities because I don't have any words squared. So I'm going to switch everything to sine and cosine. So I'm going to leave this as sine over 1, and I'm also going to leave the denominator just as plain old cosine for a minute. This is being multiplied together. Tangent is sine over cosine, and cotangent is cosine over sine. I'm going to add these two fractions together. So the sine of x over 1 is still there in the front, and then right here. When you need a common denominator, the best way is to just multiply these two denominators, or whatever your two denominators are, just multiply them together. So the common denominator is now cosine sine. So this is like a little problem inside the problem. So this denominator is cosine sine. Well, I multiplied the bottom by sine, so you have to turn around and multiply the top by sine. Sine times sine is sine squared. Again, the denominator here, I turned it into cosine sine, so we multiplied the bottom by cosine, so you have to multiply the top by cosine. And cosine times cosine is cosine squared. And then here is our trig identity from the front. Sine squared plus cosine squared equals 1. So I'm going to take this out, and I'm going to put a 1 right there. So now I have the sine of x over 1 times 1 over cosine sine. And then the denominator is just plain old cosine. Well, I'm going to multiply these two fractions together first. And the sign on the bottom and the sign on the top cancel. So now I have 1 over cosine over cosine. So I'm going to call this 1 over cosine divided by cosine. When you divide fractions, you take the second one and flip it over. So I flipped this one over and made it 1 over cosine. Straight across the top is 1, straight across the bottom is cosine squared. And of course, you really don't want a fraction, you want a single word. 1 over cosine squared is secant squared. They're not all like that. Some of them are super fast, So I don't want you to get frustrated or think every single problem is like that. Some of the rest of these problems are faster than that one even. So let's go through this again. If you're bad at common denominators, time's up. You got to get a little bit better at it. I know that doesn't give you much time, but this is how this is going. So cosecant is 1 over sine. And sine, of course, is sine over 1. Do not cross off these cosecants. That just proves that you don't understand the algebra. You cannot cancel. You cannot divide. This is a division problem right here. You cannot divide unless you're multiplying, and the numerator is subtracting. So don't cross that off, please. Please, please, please. So I erase this, but let me fix this. I'm going to leave this cosecant just alone for 1 second. So I have only one denominator in this numerator, and that one denominator is sine. So I multiplied the bottom by sine, so I have to multiply the top by sine. So now across the top I have 1 minus sine squared. Well, 1 minus sine squared is cosine squared. So now I have cosine squared over sine divided by cosecant. Okay, so cosine squared over sine times cosecant is really, divided by, cosecant is really 1 over sine. So now I'm going to flip over my second fraction. You can probably already see I'm trying to go through this very repetitive. The signs are going to cancel. So the answer to this one is cosine squared. 1 minus sine squared right away. That is cosine squared. So now we have secant A times cosine squared. You don't need parentheses, I just did that. So secant is 1 over cosine. And cosine squared is, of course, itself. And now we can reduce diagonally, and we multiply straight across the top, straight across the bottom. Cosine A. I don't know why a lot of these have cosine in them. It's just the way they're working out. It's coincidental. I don't want you to think every answer is either 1 or cosine, because that's not true. So for number 8, let's take a look at this. The numerator, remember, algebra. This is algebra with the trig words. They have the word sine in common. So that's coming out. So we're left with cosine squared plus, well, if there's sine to the third, we took one out. That's sine squared. And we love that because that turns into 1. This right here is a 1. So now I have sine of A over sine squared. And these cancel. 1 on the top cancels with the 1 on the bottom, so 1 over sine is cosecant. These are a little bit rough. Just try it. If you get frustrated or if you get stuck, just stop. Try the next one. If that's frustrating, stop. But you got to try something. You can switch everything to sine and cosine, and if that's as far as you get, that's as far as you get. If you have a blank paper, it's hard to know how to help you, because you got to try something. If you try something that's wrong, it's easier to fix and come up with another idea than it is to just do the whole problem all the time over and over again. So just try something. Please try something.